Hello friends, this is Durga from IT Varsity, a one-stop shop to learn all the technologies. At this time, we are discussing about schedulers in Hadoop, especially in MapReduce execution framework. So far, we have covered the overview about the schedulers, and then we have looked into the FIFO scheduler, and now we will get into the next scheduler, which is called as phase scheduler, which is very important if you are dealing with Cloudera distribution of Hadoop. Even in the certification perspective, probably they might emphasize more on phase scheduler because phase scheduler is default scheduler in Cloudera. So before getting into the details, let us understand how the scheduler is configured. Okay, for that we have to open the Cloudera manager. So I'm sharing my screen here. Share. Okay, now you will be able to see my screen. I'm going to uh, my browser, and here I'm in the Cloudera Manager web interface. Scheduling is primarily a part of MapReduce job execution framework or yarn application execution framework. So you will go to yarn and click on configuration, and here you can search for scheduler and hit enter. So you can see here, when you actually view the parameter yarn resource manager scheduler class. So this is the parameter name, yarn resource manager dot scheduler dot class, and you can see it can take one of these three values: the phase scheduler or FIFO scheduler or capacity scheduler. I haven't changed anything after setting up with respect to scheduler, but when I actually search for this parameter on the name of scheduler, we can see that it is already configured for phase scheduler. If you go to the similar page in Hortonworks, and if you try to search for scheduler parameter, it will be pointing to the capacity scheduler. So capacity scheduler is default in Hortonworks, and phase scheduler is default in Cloudera distribution. And then there are bunch of parameters which might be part of phase scheduler in yarnside.xml. So if you go to the command prompt and go to the node where the resource manager is running. So let us go to 243 or 244 where my resource manager is running in high availability. So now I'm connecting to 243, one of the nodes which is running the resource manager. And as I have explained earlier, to check the runtime parameters when you are running the cluster using Cloudera distribution, you have to go to this location where run Cloudera SCM agent process and ls-ltr, and scheduler is part of resource manager in because it is part of yarn, and typically the scheduler is controlled by master and resource manager is the master for yarn. Hence you have to go to the latest directory of resource manager, which is this one. If you have multiple ones, you have to pick the latest one based on this number, the first the 3-digit number, which is the prefix of the directory name. Okay, and then cd paste, hit enter, ls-ltr. You see this yarnset.xml file. You can open the file here and search for phase. And you can see there are multiple parameters. One is which defines the scheduler class, which is nothing but phase scheduler here. And then there are a few other parameters for using default queue for everything. Typically, we don't touch these parameters. Only thing which we will be taking care is we might end up defining multiple queues for phase scheduler, which I will explain in a moment. So before understanding about creating queues in phase scheduler, let us understand what is phase scheduler itself. So for that purpose, you can actually go to Google and search for Cloudera phase scheduler. Okay, and it takes you to the resource management Cloudera. And here it talks about phase scheduler. We are talking about version CDH 5X. So I will recommend you to view this URL. Okay, and zoom in a little bit here. And here it gives the details about the phase scheduler. And first, to understand the theory, you need to understand this first statement. It says phase scheduler is a method of assigning resources to application that all apps get on average an equal share of resources over time. So as the name suggests, the scheduler will try to be fair for all the jobs that are running at a point in time. So let us understand how it works by running the jobs. So here I'm coming out of this one and coming to 242. Okay, and now let us see whether there are any jobs running on the cluster. Okay, right now there is no job running. I'll be running word count program using NoHub, and I will be giving path as 01 because word count is used already earlier to demonstrate FIFO scheduler. Now I will be running two jobs, one now, the second one after a while. We'll be trying to run the similar job both the times, which requires 368 capacity to complete the job. Now I ran this job. I have submitted using NoHub and ampersand, so it will be running behind the scenes. You can monitor it by running mapped job list, and if the job is submitted and if it is running, you will see it as part of here. Now we will take this URL. Make sure we start Foxy proxy. Yes, Foxy proxy is running here. So I will start the job here. Sorry, I will paste the URL here to see the status of the job. So Foxy proxy is currently not running. That's why it is not starting up. Yeah, it is running. So it should come up. Now you can see we have started the job at 10:15. So we will actually start here. Job ID. And the job ID is this one. Okay, and here the total capacity of the cluster is 16. That one is that one you can actually get it using these values, memory and the vCores. And then time, the job is started at 10:15 or 10:14 p.m. So in the beginning, you can see that everything is in waiting state. Let us click on this one to see the action directly. Here it will only say total and completed. It does not say running. To get into the running details, it will be a good idea to actually click on this URL. I'm not sure why it is taking such a long time to open that URL. Okay, so here application master actually cut, paste. Here we will say required capacity for this job. It is 368. And one of the application master is running. And mappers, sorry, pending, running, completed. And earlier when it started, almost everything will be in pending. 0 might be in running and completed will be 0. But immediately, as we have the complete capacity of 15 after one for application master, immediately it will change to 15 here, and pending will change to 353, and this 353 includes both mappers and reducers. Like that, it will start executing the job. Now at the current time, which is 10:17, okay, required capacity for the job is still 368. Application master, one of the application is master is running, and 282 are pending. 282 plus 8 for reducers, 290 are pending, and completed are 63, and running are still 15. Now let us run the second job. Okay, I'm running one more job here. In this case, I'm giving word count 02 as the path. So this job also should require 368 capacity, and let us review that it started running. When we actually start the job ID is 0004. Okay, and let's say we have started at 10:17. Okay, 16 is the total capacity, and 10:17 is the time which it is started, and it requires 368. And as 15 are pending, 15 are running here, nothing will be started. So everything will be 0 except pending will be the total capacity which it requires to complete the job. At the time when the job is submitted, it will start like this. Okay. Now let us take this URL for 0004 and open it in the Firefox browser, because the Foxy proxy is running only in Firefox, and see what is the behavior. And also let us refresh this one. At this time it's 10:19. 10:19 p.m. So these ones will be the same. These ones also will be same. And now we will see. So here still it is refreshing. Let me click on this links. There is another way to actually get the details by running mapped job list. And now you can see that even the second job has got some resources. Okay, so we will see what are those resources it have got. So now you can see that at 10:19 or 10:20, only 7 are running, not 15. 109 are completed, and then 252 are still in pending state. So for this job, application master is 1, 252 are in pending state, and only 7 are in running state, and 109 are in completed state. And now for job 4, you can see that already it started getting the resources, and you can see 6 are running, 9 are completed, and then 353 are in pending state. Okay, and one of them will be taken care by application master. So you can see that 2 for application master plus 13 for running. So 15 are currently running. One will be just in transition state. At any point in time, it can go up to 15 tasks. There might be a few lesser if a task is just completed, and if a pending task is just about to move to running state, you will see the running number might be a little bit lesser than the total capacity, but it is very close here. So 13 for the map tasks that are running for both the jobs, and 2 for application master. So 15 tasks are running at a given point in time. One task might be in the transition stage. So the main point which you need to understand here is the phase scheduler will try to allocate the resources evenly for the for all the running jobs at any point in time. So that is the first point which they are highlighting here. As we have demonstrated, Phase scheduling is a method of assigning resources to applications such that all running applications get on average an equal share of resources over time. Okay, so that is what is phase scheduler. So by default, the phase scheduler bases scheduling fairness decisions only on memory. So it only decides based on memory. It can be configured to schedule with both memory and CPU using the notion of dominant resource fairness developed by. So you can ignore that part, as long as you understand the first point, that is fine. And another important point is the scheduler organizes apps further into queues. So you can create a queue, you can create production queue, you can create a development queue, so that your production queue and development queue get minimum amount of resources. For example, if you say your development queue is 25% minimum, and if production queue is 75% minimum, at any point in time, if the production queue requires more than 75%, it will get the 75% resources by grabbing the resources from the development queue, which is only 25%. So again, you need to understand a little bit in detail. For example, let's say you have development queue and production queue. Okay, so this is 25% of the capacity, and this is 75% of the capacity, and these numbers are minimum. Okay, so in this case, the development will, so we have 16 as total capacity, so development queue will get 4 as minimum capacity, and production will get 12 as minimum capacity. Now at time t1, so this is at time t1, there is nothing running on the cluster, and you have submitted a development job which requires 100 tasks. So as there is no production jobs running, development will start using all the capacity to start executing the job. So at T1, when the development task is submitted with 100 tasks, even though the queue defined for development is only for 25%, still it can use up to 16 tasks to process the data, as up to the point when the production jobs are submitted. But when the production job is submitted, and if it requires more than the 75% of your cluster capacity, then the development will be using only 4 tasks at any point in time to submit to complete the job, and production will be using 8 tasks as long as it requires more than 8 tasks to complete the job. So that's how the production will actually get the minimum resources from the development as and when it is required. So at any point in time, the phase scheduler will not try to exhaust the resources or hide the resources for the more important queues like production to run the jobs for development. As long as capacity is available, it will try to use the capacity, as much capacity as possible. Only when there is a contention, then it will decide that it allocate minimum amount of resources for all the queues that are defined as part of the phase scheduler. This is one more very, very important point which you need to remember when it comes to phase scheduler, and this is defined by queues. By default, there will be only one queue which is named as default, but if you want, you can create multiple queues. And the way you can create queues, let me so you should read this document to understand more about queues and how they are defined. So here, hierarchical queues with pluggable policies. So this is how you can actually give the queue names. Let me see the parameter names. The phase scheduler supports hierarchical queues. All queues descend from a queue named root. Available resources are distributed among the children. A queue's name starts with the names of its parents with periods as separators. So a sample queue. So this is how queue looks like. And yeah, these are the additional allocation files which you will see when you have multiple queues, and these will be part of their own XML files. Okay. And the way you can actually define the queues is by using the Cloudera manager itself. If you are using Cloudera distribution, you can go here and you can say queue, and you can give the phase scheduler allocations similar to this. Okay, so it will be better if you have your own cluster to practice a little bit. But from the certification point of view, the questions will be theoretical, so it is not very important to practice as long as you understand the concept of what is phase scheduler and how it allocate the resources for multiple jobs, and uh, how you can create multiple queues with minimum amount of resources, and how it works when there are multiple queues. Um, those things are more important than the configuration itself when it comes to using Cloudera, when it comes to giving Cloudera certification. Okay, let's see if there are any allocations on 243 before we wrap up this session. So I am logging into 243, and then I am actually going into the directory CD612. So you have this phase scheduler.xml, that is the file. Okay, and as of now there is only one queue, but if you want you can give more queues for the documentation purpose. Again, you can go back to this page, and this is how it looks like. They have given sample queue, and they have given minimum resources and maximum resources. So that is the capacity which it will try to use while submitting the jobs or running the jobs in this queue. Okay, that being said, I hope you are enjoying the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about big data certifications, please join my LinkedIn groups called ITversity Big Data R Certifications. And also I run a website called www.itversity.com. Please do visit and provide the feedback. And also, if you like the content and if you want to fund me so that I can come up with more and more content like this, you have donate with PayPal icon or button on almost all my website pages. And also you can use the fan funding or support this channel concept of YouTube to fund me so that I can work on more and more content like this over time. Thank you. Bye.